Hey, Programming 12. We are now going to be talking about the coordinate system within processing because it's a little bit different than math, and also talking about the drawing functions. We're going to review your line function, rect, and then square, its friend, ellipse and circle. Let me think. Triangle, the trickier one, and then quad as well. Those are the functions we'll go over today. Okay, so first of all, the coordinate system is a little different. I have a diagram here that shows sort of on one side we have the 8th grade, what you learned in the 8th grade of what the coordinate system should be. And the origin, 0, 0, is in the center, and as you go up, y increases, and down, y decreases, right? And x to the right increases, and to the left decreases. So that's how it works in math. But in computers, and this isn't just processing, by the way, this is all computer, hardware, software, unless, it has to undo it if it changes this. But basically, here's the story. The origin is in the top corner. So 0, 0 is actually the top left corner of the screen. And then the x-axis is fine. It's okay. It increases going to the right as well and decreases going to the left. But the y-axis is actually upside down. So you actually increase as you go down the y value. So that's shown here on the right-hand side of the screen. So that can be confusing sometimes, and we did a bunch of projects to practice that and get that under our belts. And if you're new to processing, you might need to do a bit of practice on your own as well. We'll have some activities coming up where you'll get that practice. But if it's not coming natural, don't worry, that's just because you got to practice a bit more. So let's go and use this knowledge now to learn about the different drawing functions. So I'll go back to processing. You'll see I already started using them like rect and ellipse. I think a lot of the challenge comes from just remembering what these numbers do. This is like a list of 4 numbers, and sometimes students just get confused with what they do. So we'll just make a list of these functions and remind you of what the values of those numbers mean, and then we'll go from there. And we'll give you an activity in a couple of videos. You'll have an activity where you get to practice it, and then you can show me that you understand. Okay, so here we go. I'll just put a comment on the end. We saw a rectangle makes, you guessed it, a rectangle, or a rect makes a rectangle. These first 2 numbers are the xy coordinates. So in order, these arguments, they're called, the numbers that you send it, are x and y, and then this is width and this is height. Width and height, that's how I'll encode that information. So that, just have to remember that those are the numbers. So if you wanted to make the rectangle higher and stay the same, width and height, then you would say change this number. Let's make this, so this is what it looks like right now, sort of nicely tucked into the center. But if I want it to go up, I could make this say 0. I'll decrease it, and then it will go up. Isn't that weird? If you're not used to it yet, don't worry, you'll get used to it. See how now it's higher up? Now you might be wondering, okay, so that number there is the coordinates of the rectangle, but what aspect of the rectangle is at that coordinate? And the answer is, this is the top left rectangle, top left corner of the rectangle by default. So 100, 0 is this number here, like 100 along the x-axis and 0 along the y-axis. So that number keeps track of the top left-hand corner of your rectangle. We learned, though, that we can actually change that so that it defines the center using the rect mode, but it's not essential to remember that right now. But in case that's something you were like, oh yeah, how do you do that? Rect mode, center is the way to make that happen. I won't go over that too much detail. Width and height are just measured in pixels. So, you want to make it fatter, make this number change. You want to make it taller, change that number. By the way, there is a square as well. So square, you again give the coordinates. So I could say 100 and 100. But you only give one number for width and height because it's a square. So you don't have to give it any more numbers. So if I say 200, the width and the height will be 200. So this is x, y, and then I'll just like size, like, just the side length of the square. Okay, next we have the ellipse. An ellipse, of course, is a circle shape, but it can be like an egg shape, right? It can be like stretched out in different ways. So these numbers here, again, are the x and y coordinates. And they represent the center of the ellipse, in this case, not the corner. So this is our center of it, and then this is the width and height of the ellipse. So here's our width and our height, just to keep that information remembered. So if we run this, I'm going to have a square up here now. Well, that doesn't look very square, does it? Oh, yeah, it's actually underneath the ellipse. Let's just get rid of this ellipse for a second. Let's just to see that square. Yeah, there's this square. There's this square there. And our ellipse is on top of it. Yeah, so our ellipse, you can see that this is a circle because the width and height are the same. So, you know, if you change that, if I was to make this, say, 100, it would get skinnier because that's our width. So it's just less width. And it shrinks, you know, in towards the center because this is still the center of the ellipse. So if you make it skinnier, it'll, you know, suck it in from both sides. You can make it taller or shorter or whatever with this number here and move it around. If I was to put this at 0, 0, where is it going to be? Just mentally imagine, what would you see? If I had made this change, how would you imagine, like, what would be the new coordinates? And it turns out, yeah, it's up in this corner here. That's 0, 0, right? So you actually don't see it, and it's okay. You can actually draw off screen. I can actually say negative numbers too. I can say negative 50, and it will move, you know, you can just see the very edge of it there in the corner. So so that's basically what's going on there. I'm going to put this back to where it was, though. Control Z undoes. There we go. So yeah, we're back. We're good. Okay, just like we have square, we also have circle, which is exactly like ellipse. You give it the X and Y, but then again, you only give it one number, and that represents, again, the size. So X, Y, and I guess we could say it represents diameter. Is a good way to describe that. It's the distance across the circle through the center. So if we run that, we can see it's kind of like a sideways eye. Nice. Art. Kind of. Oh, and of course we need the line function. A line simply just draws a line. It connects 2 points. So for a line, you'd say, you know, 2 sets of XY coordinates. So I said 0, 0, and I said 400, 600. Then I would get myself a line that goes from the top left corner to the bottom right corner. So we can see that, yeah, look at that line, just cuts straight through. Nice. And then I should mention that, you know, this number happens to be the same as the size of the screen. If you ever want to just, you know, if you don't remember what the size of your screen is, remember there's built-in variables like the word width and height. These are built-in values that remember what your setup size was. So if you are like wanting to say, oh, it's you know, width and height, then it'll do the same thing. It'll go there. You can even do a little bit of math on this. So if you want the line to go to the center, you could do width divided by 2, height divided by 2. I mean, you could just mentally divide these by 2, but if you were to change these values later on, then it would still go to the center. Like, check this out. My line goes to the center, and my circles are hard-coded to be at the center. But if I was to change these numbers, say I change this to 600 by 600, notice that that line still goes to the center, but now these ones are off. So sometimes it pays to program, actually, as often as you can, I'd recommend programming with these values if you know that it's meant to be in the center. Don't hard-code it like this. Use those built-in variables, and then future changes you make to your project are just easier. Everything will be easier in the future. So definitely prioritize future you when you're programming. It's a little bit more work, but maybe it's not, because then you don't actually have to do any mental math. So that's cool. Okay, just to complete our notes, this is you know, x1, y1, and x2, y2. So 2 sets of points, 2 sets of you know, xy coordinates, and they connect the 2 of them together. The next one after this is triangle, and triangle is just 3 lines. They are connecting 3 points, right? The corners, the vertices of the triangle. So in the triangle function, which is just triangle, you just specify 3 coordinates. So it's a lot like line, but you give 1 more set of xy coordinates. So that's 6 numbers or 6 arguments altogether. It gets kind of tricky, but we did a lot of practice with this last year, trying to, you know, fit a triangle into the right places. So you might need to practice with that again. So let's say I did 0, 0, width divided by 2, height divided by 2, and width 0. Oh, you might have to put on your thinking caps to like imagine where is that. So just think about where is this point, where is this point, and where is this point. You can even pause the video if you want, just to like have a bit more time to think about it. So what kind of triangle are we going to see? Well, that's going to connect the, the top two corners and the center. This is the first point, the second point, and the third point. You might wonder, oh, well, what happens if I put the center first? Would it mess up my triangle? And the answer is no, that actually works just fine. If I put the center coordinate first, it doesn't change the triangle, because the order it connects them still creates the same triangle. If it goes, this way or this way or this way, like it still creates the same triangle. So it doesn't really matter where you put the coordinates as long as you group the right set of x, y's together. So, to make the comment, this is x1, y1, x2, y2, and x3, y3. There you go. Triangle's getting hard. Guess what? There's also a quad. A quad is a four-sided shape that, you could make a rectangle with, but you're most likely going to make like trapezoids and, size non-conformist four-sided shapes. Wait, that's not the right mathematical term. Quadrilaterals is really the mathematical term, hence quad. So what this will let you do is specify 4 points, and we'll connect them together. And this one, actually, the order can matter. You can end up getting like an hourglass shape or like a figure 8 kind of shape if you go in the wrong order. So in quads, it actually matters. So go around clockwise around the points that you want to connect. So gosh, if I did 0, 0, and then I did, let's go around the whole thing. Let's just obliterate the whole thing. 0, 0, going over to the right, that would be width 0, and then it would be width height, and then it would be 0 height. And so there's 4 sets of coordinates. It's top left, top right, bottom left. And if we run that, the square should, we get this basically a rectangular shape that covers the whole thing. If I was to slightly alter these though, like if instead of 0, 0, if I said like 100, 100, not 1,000, 100, notice that the triangle is showing through in the background there. Maybe I'll just comment these out. Ooh, big secret. Command/. Yes. Just comments out a whole bunch of things. You can press Command / and reintroduce your code, but you can just turn off code with Command/. So good. So now we don't see this. But see how, like, if I change that one coordinate, it's like, bends those lines in. So you can make some really interesting shapes with quads, and it's beautiful. So this is exactly like a triangle, except it's got an extra set, an x4, y4. So there you go. There's our drawing shapes. So we're going to pause the video here, and then we're going to talk about colors. How do you, change the inside color? Right now it's default white with a black outline or stroke. So how do you change that color? How do you represent colors in processing? All that good stuff we're going to get back into. Okay? Thanks, everybody. Hope you're enjoying the lessons. And I am definitely enjoying giving them to you. I hope you can tell. Okay, bye, everybody.